Okay, we're going to be looking at solving equations that contain a single log. And we can have the x in three different spots. The x can be over here as the answer to the logarithm, the x can be the base, or the x can be in the argument. So we're going to look at all three types. We're going to start with this part right in here, where the x is on one side by itself and the log is the other. So problems 1 through 6 are going to be like this. And I realize that you could just stick this into the calculator and get your answer. But by doing so, you're going to lose a lot of meaning along the way. So we're going to take the time to work through these 6 problems and sort of explain how all of those are worked out and hopefully increase your understanding of logarithms. And then once we get past this, then later on in the later chapters, later sections, you can just use your calculator to obtain the answer. So problem 1, we have log base 9 of 81 equals x. What I'm going to do is to write this as an exponential. It's easier to think in terms of exponentials than it is logarithms sometimes. So if I write this as an exponential, I have 9 to the x power equals 81. Well, that is just like what we did in section 2. I know that 81 can be written as 9 squared, so I've got these two powers equal to each other. The bases are equal, so the exponents have to be equal as well. Problem 2, I have log base 7 of 7 to the 9th power equals x. And there's a couple of different ways that I can do this. If I did problem 2 like I did problem 1, the base I would write as 7. The answer over here is the exponent, so x is the exponent. And this argument here of 7/9 is what goes over here on the right-hand side of the equation. And then I can see that x is equal to 9. But let's look at this problem again. Once you begin to really understand logarithms, you don't need to go through all of those steps. This is saying I'm going to take 7 and raise it to some power and get 7 to the 9th power. Well, what power does that need to be? Well, it needs to be 9. 7 to what power is 7 to the 9th power? It's like, well, duh, it's 9. So let's scroll on down here. Problem number 3. Here I have the log base 5. The cubed root, or sorry, square root of 125 equals x. The base is 5. The exponent is the answer to the logarithm, so the exponent is x. And this is going to equal the square root of 125. Well, first thing I want to do is to take that square root and write it as a 1/2 power. Now I can take the 125 and write it as a base of 5. 5 cubed to the 1/2 power. Now my laws of exponents, my power rule says a power raised to a power. I multiply those exponents. So 3 times 1/2 is 3/2. Now I can set the exponents equal to each other. So x is 3/2. Problem 4, I have log base 16 of 4 equals x. Why don't you pause this and try to do this problem on your own. Okay, here we have x equals 1/2. Problem number 5, log base 4 of 8 equals x. And problem 6 is going to be log base 27 of 27 equals x. I'll give you a second to pause the video and try to do those on your own as well. Okay, there are your answers for problems 5 and 6. So that was the first group of problems where we had the x being over here on the right-hand side by itself. Now the next set of problems we're going to do is where x is the base. So I have log base x, 16 equals 2. I'm going to write this as an exponential. The base is x, the exponent is 2, and that is going to equal 16. Well, in order to solve this problem, I need to take the square root of both sides. Well, normally when I do that, I will take the square root of this side and get x, and then over here I normally write plus or minus the square root of 16. But remember that this x is a base, and the base has to be positive. So I'm not looking at doing plus or minus here. I only want the positive square root. So this is just going to be x equals 4. Problem 8, log base x, 2,401 equals 4. So now we're getting to numbers that are not quite easy to do in my head. So you really have to understand what the relationship is between all of these things here. The base is x, the exponent is 4, and this is 2,401. So just like over here, I took the square root of both sides. I wrote it out. I'm not going to write it out over here. I'm going to take the 4th root. I'm going to go ahead and write this in here, though. I'm taking the 4th root of 2,401, and you just stick that into your calculator, and you're going to get 7. Okay. Let's scroll on down here and do the next problem. Actually, I want y'all to try to do this one on your own. So pause the video and try to work that out. Okay, problem 9, I have the 4th root of 8 for the answer. Problem 10, x is the base, the exponent is 1/2, and the answer is 3. Now, what I need to do to solve this is to square both sides of the equation. And squaring both sides of the equation will give me x equals 9. And one thing I want to point out here is that you need to be multiplying these two numbers together to give you 1. Because really, if I wanted to go ahead and put this step in here, 1/2 times 2 is 1. So x to the first power is just x. I'm trying to get this exponent to be 1. And that is important for you to understand for this next problem here. Here I have log base x of 8 equals 3/2. The base is x. The exponent is 3/2, and that's going to equal 8. Well, I want to raise this to some power and then raise this side to the same power, and whatever exponent I have here needs to give me x to the first power. Well, what do I need to multiply 3/2 by to get 1? Well, I need to multiply by its reciprocal, 2/3. So over here, I have 8 to the 2/3 power. And 8 to the 2/3 power is going to be 4. So x equals 4. Problem 12. Notice that all of these problems are just a little bit different. It puts together a whole bunch of stuff that you have learned in intermediate algebra and early in college algebra. A lot of little basic skills that we need to know how to do. And there's a couple of different ways to do this problem. If I can do it the same way that I did over here, I didn't leave myself enough room to put my parentheses in here, so I'll just rewrite it. I want to raise both sides of these equations to the same power, and whatever exponent I put here has to multiply by -2 to give me 1. So what exponent do I need? Well, it needs to be -1/2. We multiply those two together, we get 1. So here I have 16 to the -1/2 power. And you can just stick that into your calculator if you need to. So you get x equals 1/4. All right, the next problem I'm going to ask you to try on your own. So once I get this written down here, pause the video and see if you can solve that. Okay, the answer to problem 13 is 3. Problem 14. Here's where I'm starting to have the variable in the argument. So the base here is 2, so I'm going to write this as an exponent. 2 is my base, and the exponent is 3, and that's going to equal x. Well, that's easy. That's just 8. And let's see, problem 15. Of the log base 6, 3x minus 3 equals 2. The base is 6, the exponent is 2, and that's going to equal 3x minus 3. Well, this is just a basic equation like we did in transition math. And once you get that 6 squared in there, it looks pretty easy. So you just solve this like you normally would, and you get 13 for your answer. Problem 16. Write this down and see if you can solve this one on your own. So pause the video here and see what you get for your answer. And the answer to that 1 is 14/5. This last problem is really just you going back to understanding the definition. This is asking me, when is this true? When does a to the first power give me a? Remember, if I write this as an exponential, here's my base, and that's 1, and this is a. When is that going to be true? Well, when I'm looking at a logarithm, I have to take into account that the base cannot be negative, and it cannot be 1. So this is true for any a such that a is greater than 0 and a does not equal